All right, everybody, last lesson of Calculus 12, integrating bases other than e. All right, so this is things that look like this, the integral of 3 to the power of x dx. This is not intuitive, and I'm going to show you where the formula comes from. This is actually one of the formulas that is useful to remember, okay? But it's also good to understand where it comes from. So the derivative, or the derivation of the formula. I have a to the x dx, okay? And I want to integrate that. Well, if you remember your log rules and your exponentials, I can rewrite this like this. All right, because e and natural log is base e. Remember, if you have this sort of thing, 4 log base 4 of x, that equals x. If your base here and the base of the log are the same, it's just whatever the argument is. And that's what it is in this case. This would be base e, the e, so it would just be a to the x. So these are equivalent. Then I'm going to do a u sub on, well, I guess first I can drop that x down. Let's do that. E to the x natural log of a dx. Then I'm going to do a u sub on my exponent. So u is equal to x ln of a. Then you derive it, du dx. Natural log of a is a constant, so the derivative of x is 1, so it's just natural log of a. Rewrite this, du over the natural log of a is equal to dx. Because I've already subbed this out, this is u. This dx is the next thing I'm trying to get rid of. And that's equal to du over the natural log of u. So our integral now becomes e to the u, okay? And instead of dx, it's du over natural log of a. Looks weird that we have a natural log in there, but it's natural log of a constant. So I pull that out. E to the u du. What's the integral of e to the u? Well, that's just e to the u plus c. What was u? U was, why are we not moving? There we go, sorry. U was x natural log of a, or we can just say, I can move that up, natural log of a to the x. So this becomes 1 over natural log of a e to the natural log of a to the x, plus c is still there. Remember, base and base match, so it's just a to the x over the natural log of a plus c. Now that's a lot of work, okay? You don't want to do that every time, so it is useful to remember this formula. So I'm going to summarize it down here. So what we can say is the integral of a to the x dx is equal to a to the x over the natural log of the base a plus c. So your whole goal during these questions is to get the formula to look like that. All right, because then you know what the antiderivative will be. So we'll start with a simple one. Integral of 2 to the power of x dx. Does it match this formula? It does. So it just becomes a to the x, which is 2 to the x, over natural log of the base 2 plus c. That's it. All right. Second one, integral of 4 to the negative x dx. Doesn't match this formula. We're close, but we have this negative exponent. So we got to do u sub, and you're going to u sub the exponent. So u is equal to negative x, du is equal to negative dx, and negative du is equal to dx. So this now becomes integral 4 to the power of u negative du. I pull that negative out. Now this integral matches our formula perfectly. So it's, the negative comes with it, 4 to the u over the natural log of 4 plus c, what was u? Negative x. So you might have to do a bit of u substitution to get it match the formula, but that's okay. I don't like this color anymore. Number 3. So we can make them slightly more complex. 3 minus x, 7 to the power of 3 minus x all squared dx. Now on the surface, you can see something close there. We got 3 minus x down here, 3 minus x in the exponent. But it's an exponential function because it's 7 to that power. Okay? So we want to start doing some u sub to make it look like our formula up here. Okay? So u sub, 99% of the time, you're going to u sub the exponent. 3 minus x all squared. So du dx, we're going to use chain rule, the 2 falls down, times the inside derivative, which is negative 1. Oops, erase that, that's nothing. Then I'm going to multiply the dx up. I'm going to divide off the negative 2 because I need to get rid of this and this. So I'm going to get du over negative 2 is equal to 3 minus x times dx. So that takes care of that. We've already taken care of that because it was u. So now our integral becomes 7 to the power of u du over negative 2. So I can pull the 1/2 out. And I'm left with that. That matches our formula. So it's negative 1/2 7 to the u over the natural log of 7. What's our u? 3 minus x all squared. 7 to the 3 minus x all squared over the natural log of 7 plus c. There you go. You could move this 2 up to get natural log of 49. It's up to you, but I'm fine if you leave it right there. All right. Do a trig one. You can hear everybody groan right now. 2 to the power of sine x cos of x dx. So whenever you see sine or cosine in an integral and you see, well, if you see both, that's a good thing because you know if you do a u sub and take the derivative of that u and you pick one of the trig functions, derivative of sine is cosine, derivative of cosine is negative sine. So you know that something will fall out. And because this is an exponential, your u is always going to be your exponent. So du is equal to cos x dx. How nice that worked out. So the integral now becomes 2 to the u. This bit becomes du. This matches our formula. So it's 2 to the u over the natural log of 2 plus c. Sub back in our u. So it's 2 to the sine x over the natural log of 2 plus c. There's your answer. All right. The last question of Math 12. We'll do it in black because it's a sad day. We're going to do the integral of 3 to the power of 2x over 1 plus 3 to the power of 2x dx. Okay, so this looks a bit weird. We could try substituting out the 2 to the power of x. That's not really going to work because it's in two different things. It's in there's two terms with it, I should say, in the numerator and the denominator. but you can try it and see what happens. But if you notice, the denominator has two terms, the numerator has one. And one of the terms in the denominator is a constant, this 1. I know if I take a derivative of a constant, it disappears, goes to 0. So it should be left with one term. So I'm going to try subbing out that. 1 plus 3 to the power of 2x. So we go, okay, let's do the derivative. So du dx. Now, this is going to be a bit weird. The derivative of 1 is 0, but I want to do the derivative of 3 to the power of 2x. So over here, I'm going to say y is equal to 3 to the power of 2x. You got to just kind of hold this in your mind. And if you remember from the last lesson, if I want to derive this, I'm going to natural log both sides. So I get that. And then I go, okay, y primed over y is equal to 2 natural log of 3 over x. No, derivative of x is 1. Wow. Sorry, people. So it's just 2 natural log of 3. The y gets multiplied up. So I get y primed is equal to y. I'm going to move that 2 up to get natural log of 9. What was y? 3 to the power of 2x. So that is the derivative of that. You have to do all this on the side. If you just remember how to do the derivative from the previous lesson, that's fine. Like I said in that lesson, I never do. I always do this natural log process. So the du dx here is equal to 3 to the power of 2x natural log of 9. All right. Now, we've gotten rid of the bottom. It's u. There's our u. I want to get rid of that. So if I multiply the dx up, divide off the natural log of 9, so I get this, then I can sub that out. Now my integral, change colors again just because, we'll go light green here, becomes 1 over u times du over the natural log of 9. I'm going to pull out 1 over the natural log of 9. So let's put the integral of 1 over u du. Hopefully people are recognizing that the integral of 1 over u is the natural log of u. What was u? Boom, 1 plus 3 to the power of 2x. So this whole integral becomes 1 over 9 natural log 1 plus 3 to the power of 2x. You don't have to put absolute values because that's always going to be positive. Tack on a plus c and you are done. I'm not sure anybody would have realized that the integral, just to summarize it here, the integral of 3 to the power of 2x over 1 plus 3 to the power of 2x dx would be 1 over the natural log of 9, natural log of 1 plus 3 to the power of 2x. Not totally intuitive, but just be careful. If you have a numerator and denominator, try making your u substitution on the denominator if it has two terms, or the numerator if that has two terms. Remember, when you're doing the derivative of that, the derivative of an exponential, you have to use the previous lesson to do that. It's a little side derivative. The goal of every one of these is to make it look like, if you can, our formula. So you're going to use some exponent, get it into our formula, and then you can use the proof that we did way back here to get that. All right, that is it for Calculus 12. Here are your questions, 363, numbers 71 to 83. Congratulations on completing this course. Let me know if you have any questions.